it's cool going from a design and an idea to a final product that's really well built, and if I can just see it in my head being this like glowing box of just, you know, like work and sweat and labor that just winds up being like it works perfectly, just the way you want it, just the way you've been planning on it working, you know, for probably 6 months, you know. My name is Kifer. I'm double majoring in computer science and physics, and I also have a minor in math. I'm researching this summer, doing work with Professor David Murr, who works in the space physics lab, and I've got my funding through the McNair Foundation. Well, primarily my research is focusing on building a weather balloon payload that is going to be capable of tracking what altitude and the temperature and pressure as, you know, the balloon goes up into the air. Others are going to be able to use this by essentially taking our model. We're hoping that other, you know, schools or research groups that, you know, schools like, you know, maybe on the size of our school, Augsburg, they may not have the funding to, you know, launch a full-scale balloon launch with investing money in researchers, building these sample gathering payloads. We kind of want to have like a basic layout where we can say this is a really easy model to follow and it's really inexpensive and light. They'll be able to launch their own balloons, you know, and collect air samples. At this point, you know, there's a lot of MacGyvering going on, that's for sure. But I mean, by the end of the summer, we plan to have a really well laid out design, you know, with our own printed circuit board where everything is, you know, soldered in place. It's going to be just like if you were to buy a computer chip, you know, at the store, it's on a board that's really well built and designed.